Everyone talks about the AI race as a race between algorithms. Who has the smartest model, the cleverest researchers, the best training technique? That's the wrong frame. The real race is about compute. Who controls the physical hardware capable of training frontier AI systems? And that race has a far smaller, far more concentrated set of winners than the public conversation suggests. Training a frontier AI model today requires tens of thousands of specialized chips called GPUs, graphics processing units repurposed for AI workloads, running continuously for months, consuming enormous amounts of electricity and costing hundreds of millions of dollars per training run for the largest models. The company that designs the overwhelming majority of these AI training GPUs is Nvidia, giving it a market position in AI compute that is arguably even more concentrated than ASML's position in chip-making equipment. This creates a layered chokepoint structure worth understanding. Nvidia designs the chips. ASML's EUV machines are required to manufacture Nvidia's most advanced chips. Taiwan Semiconductor Manufacturing Company, TSMC, actually fabricates them using those machines. This means frontier AI compute depends on a chain running through exactly 3 companies concentrated in exactly 2 small geographies, the Netherlands and Taiwan, with the US and China as the 2 countries racing to secure access and build alternatives. The US government has used export controls to restrict China's access to Nvidia's most advanced AI chips, on the logic that whoever trains the most capable AI systems first gains meaningful economic and military advantage, from more capable weapon systems and intelligence analysis to breakthroughs across science and industry. China's response has been twofold: building domestic chip design and fabrication capability, largely through firms like SMIC, while also becoming remarkably resourceful at building capable AI models that use compute more efficiently, extracting more capability out of a smaller and less advanced chip base than Western labs use. That efficiency angle matters more than most coverage admits. Several Chinese AI labs have demonstrated that clever engineering, more efficient training techniques, smarter architecture choices, can partially offset a compute disadvantage. This doesn't eliminate the importance of chip access, but it does mean the AI race isn't a pure hardware story. It's a race between raw compute scale on one side and compute efficiency innovation on the other, with both sides pursuing every advantage they can find. Why should a business leader or policymaker outside the tech industry care about any of this? Because compute access is becoming a national strategic resource, similar to oil in the 20th century. Countries and companies without access to frontier compute are increasingly locked out of frontier AI capability, which cascades into everything from advanced manufacturing optimization to financial modeling to defense applications. Nations are responding by pursuing what's called sovereign AI, building or securing their own compute infrastructure, rather than depending entirely on foreign providers, a topic worth its own deep dive. For Africa specifically, the compute gap is stark. The continent has minimal frontier AI training infrastructure, meaning most African AI adoption today is built on top of foreign-trained models accessed via API, rather than African-owned compute or African-trained frontier models. This has real strategic implications. Dependency on foreign AI infrastructure means dependency on foreign policy decisions about what that infrastructure can be used for and by whom. For businesses building AI strategy, the practical takeaway is to separate 2 very different questions. Do you need frontier AI capability, which requires this entire compute supply chain? Or do you need practical AI application, which can often be built effectively on existing models via API without needing to own any of this infrastructure yourself? Most businesses, including most African businesses, sit firmly in the second category. And conflating the 2 leads to wasted capital chasing infrastructure that isn't actually the bottleneck for their use case. The AI arms race is really a compute arms race, running through a handful of companies and 2 small geographies. Understanding that chain, Nvidia, ASML, TSMC, tells you more about where AI power actually sits than any conversation about which chatbot is smartest this month. This analysis is for informational and educational purposes, drawn from public reporting, shipping data providers, and government sources. It is not investment, legal, or policy advice. This is the Katakyie Brief. While everyone talks about the military side of geopolitics, we track the boardrooms, the balance sheets, and the breakthroughs that quietly redraw the map. Because the next war for power won't just be fought with weapons, it'll be fought with technology, capital, and ideas. If you want to stay ahead of that